Okay, I think we can kick off, everybody. Thank you, everyone, for joining today's technical breakfast briefing. My name is Pratap Rajagopal. I lead a global solutions architecture team for Ciena, focused on our routing and switching solutions. I want to welcome you to today's first session in our new technical briefing series. These are intended to be an educational session on a variety of relevant IP topics for the Australian New Zealand community. In today's session, William Brioski will talk about SRv6, the state of the art in 2023. SRv6 is a very broad subject, so this will be part one in a series of webinars specifically focused on SRv6. We do need to let you know that we are recording today's session, and this will be posted afterwards for people's viewing. Please do ask questions throughout the session using the Q&A function. We'll either answer directly during the call if we have time, or take them offline and follow up separately. Just quickly about William. William is based in Melbourne. He's a routing and switching solutions architect in my team, and he's responsible for consulting with Ciena's APAC customers to assist in the evolution of metro architectures within IP solutions. With that, I'll hand over to William to take you through part one of our SRv6 session. Thanks, William.
Thank you, Pratap. Thanks for the introduction. Good morning, everyone. So let me get started. We have quite a bit to get through. So what we would like to address today is really some of the basics. So what is SRv6? How does it look like? We'll start looking at bits and bytes. Not that much in this session, a lot more in the following ones, but let's have a bit of a look. Why should I care? Is it important? What are the pros and cons? And is it urgent? Do I need to just go and replace my existing network, or maybe it's not that dramatic? And then also a bit of a look at outside of the world, who is already adopting SR and SRv6? And if not, what are the barriers? What are the challenges to getting started? For the engineers in the call, there will be a few of the usual buzzwords, so slicing, cloud, SDN, and so on. I'll minimize the use, but it's part of the industry. So let's start from the beginning. Back in the days, in the late 1990s, ATM was the dominant underlay technology. Until MPLS came onto the stage. So towards the end of the 1990s, MPLS came into existence and very rapidly became the dominant underlay technology. Now, ATM didn't die overnight. It was a long period that ATM survived, maybe due to inertia. But it was clear, particularly that MPLS was superior from many points of view, including cost, versatility, and others. And it was pretty clear everyone really jumped on board. Now, it seems that we're seeing something similar in the last 5 years or so. Segment routing has started in existence and very quickly started picking up. And again, we're not seeing MPLS disappearing overnight. We're probably the beginning of the long tail of MPLS getting into oblivion. But we can observe that segment routing is definitely the new kid on the block. Now, if you look a bit more closely, there's a bit of a difference between SR-MPLS, which is segment routing with MPLS data plane, and SRv6, which is segment routing with IPv6 data plane. SR-MPLS has definitely picked up quickly, and while SRv6 seems to be lagging a little bit. So we'll see what are the reasons for it, what are the challenges towards earlier adoption of SRv6. A bit of a look at the state of the industry in MPLS before segment routing. So as you probably know, there's a lot of protocols, there's a lot of options. Each of the protocols is optimized for a small set of use cases. For example, LDP is really great for its simplicity, but it has shortcomings. It's probably too simple, so it doesn't support traffic engineering. It doesn't support well things like faster route. Vice versa, RSVP is great for traffic engineering and faster route, but it doesn't scale well. So between the pros and cons, the common situation in today's networks is that operators use a combination of protocols, LDP and RSVP, and combinations, and maybe BGP-LU and so on. So what's the problem here? Well, you have a lot of protocols, which really lead to complexity. Complexity means cost, time to market, slower time to market, complex design operation, and so on. So what does segment routing bring to the table? Starting, I'll look at segment routing with MPLS data plane. It really replaces by design all of your conventional, traditional protocols to operate MPLS with just a single protocol. You actually don't need any additional protocol. It leverages extensions to the IGP. It intentionally covers all the use cases that would have been covered by the fragmented MPLS traditional protocols. And it also, in addition, deliberately has support for interworking with the traditional MPLS. Why? Because no operator wants to rip and replace their existing network, do a massive truck roll and replace it with SR-MPLS overnight. So what we see is that normally you have deployments of so new deployments may happen with SR-MPLS, while the rest of the network is still on traditional, and you really need to do the interworking. So that's intentionally covered. SR-MPLS addresses pretty much all the challenges that you could raise for the traditional protocols. It comes with its own new challenges. We're not going to dig deep into those because the webinar today is more about SRv6, but keep that in mind. So the long and short is that the SR-MPLS gives you a simple but powerful platform to operate on. Now, if you want one shortcoming, is that in terms of very high scaling, it still depends on BGP-LU, the same way that traditional MPLS does, which unfortunately still means a bit more complexity and means it's weak on the traffic engineering SDN, centralized controller scenario. There isn't really a good industry-wide solution for inter-domain traffic engineering yet. Now, moving on to SRv6, same idea, one protocol to rule them all, cover all the use cases, remove the well-known challenges. Now, on top of what SR-MPLS provides, SRv6 also introduces the high scalability without the need for BGP-LU or similar solutions. It may leverage BGP itself, but the big difference here is because now the segment identifiers are IPv6 addresses with extremely large addressing space, we can do things like prefix summarization, and that brings scaling to a completely new level, well beyond what BGP-LU would be capable of, because you cannot do summarization in a MPLS space, but we do without segment routing. Programmability, in SR-MPLS, the segment identifiers correspond to network entities, so nodes, links, paths. In SRv6, in addition to that, segment identifiers can also map to functions, behaviors, things like service chaining can be encoded directly in SRv6. And of course, again, interworking with MPLS for gradual introduction, interworking with IPv6. One important angle for interworking with IPv6 is you can actually transport SRv6 packets over a plain IPv6 network, which is not enabled for SRv6 as such, it's just routing IPv6 packets. You just get a best effort behavior, but you can use that as your transport, and that will become important, for example, in the data center. So to summarize, again, all the use cases with on protocol, high scaling, and additional capability. Looking at adoption, there's going to be a few slides presenting stats. These come from a survey that Siena commissioned last year from interviewing global service providers. Now, highlight of this particular slide is segment routing, not differentiating between MPLS and SRv6, is basically the reality here already. So that confirms our first slide on the history. It is here. Everyone is doing it. If it's not, if it wasn't last year, it would be this year. So everyone, 100%, is either deploying or has concrete plans for segment routing. Again, this doesn't mean that they're replacing and transforming the whole network into segment routing overnight. The typical approach that we see all over the place is new deployments are, well, the default choice is segment routing, or when there is a natural refresh point, again, it may be an opportunity to update the technology. But quite often what's already there, it's already working, it stays for the rest of its useful life until it's really time for a life cycle event. What do people do? What do they intend to do with segment routing? This is a busy slide, so just highlight a few of this. So 5G transport, that's definitely something that comes up with any operator engaged in that space. Why people want to use segment routing? Slicing is definitely something that comes up. Segment routing is one of the building blocks. But a common conversation is, I want something that's future-proof. I want something that doesn't bring me to regret spend. I don't really know what's coming later. I want, the most powerful, more flexible, versatile platform that technology gives me today. A couple of others. Uniformity across the WAN and the data center. This is really one that works best with SRv6. We'll zoom into that in a bit. And in a way, it's often related to 5G, with 5G basically mandating disaggregation. All your traffic will have to transit through the data center. So optimizing, simplifying that interaction becomes very important. Just another one at the bottom. Not everyone is interested in multicast, but if you are interested in multicast, you know that MPLS is a nightmare when multicast comes into the picture. SR-MPLS doesn't really address that well. There's technology out there, but nothing that really tries to simplify and give you an organic solution. SRv6 is capable of addressing that use case very well instead. Looking at the interaction between WAN and DC, you may notice the connected cow here. So obviously you will have a client out there that needs to interact with an application in the data center, in our case, cow. This could be, again, your 5G or beyond Internet of Things slice. If you implement this kind of application, this use case, on when your WAN is running any sort of MPLS, including SR-MPLS, then you find that MPLS is not available in the data center. It just never happened. Some vendors tried to push it in. It just it's not the way the data center works. So the underlying data center is based on IP, be that v4 or v6, commonly v4, and probably VXLAN. That's kind of the industry standard these days. And instead you have an MPLS-based underlay in the WAN. So you have two drastically different underlays. You need to worry about how to get them to communicate with each other. Probably on the overlay side of things, you may need to break up your service into segments as well, into portions, just because the underlays are so completely different. Now the diagram at the bottom shows how you could do that with the SRv6. Now if your WAN runs SRv6, if the data center runs a plain IP v6 underlay, you can federate those together. Now you have two compatible underlays. You can have your overlay service running end-to-end from the access side all the way to the data center endpoint. The only thing that really needs to be enabled for SRv6 in the data center is the endpoint on the right. The switching infrastructure data center doesn't have to. So as you can imagine, this is a big improvement. Now, add on top of that you can encode functions. Remember, service chaining, all of that directly into SRv6. So this becomes very powerful. So we've shown a few options, a few reasons for which SRv6 should be really interesting. But going back to the survey, if we now differentiate between SR-MPLS and SRv6, we see that only 20% of the respondents had concrete plans for SRv6. Now, keep in mind, this was 1 year ago, so a very small portion of the respondents had already deployed, but it was obviously starting to pick up. Now, why it's only 20%? Why it's not 50% or more? Because if we agree that SRv6 is better than SR-MPLS, then everyone should use that. So let's quickly look again at a few extra motivations, and then we'll look at what are the challenges, what are the barriers, why it's only 20%. So motivations, again, busy slide. I'll highlight a few things. So there are themes here. Simplify, ease. So there's clearly one driver trying to simplify things. Optimal balancing, scale. So SRv6 is perceived as more powerful, more capable solution. Future-proof. Remember, future-proof, no regret spend. Being open to whatever comes later, digital transformation or whatever else might come in the future. I don't really know yet what it is, but I want to be ready. And finally, interworking. Again, it's not a rip and replace, it's a gradual introduction. So simplification, future-proof investment, better capability, and obviously no disruption. That's how we want it to happen. Now, why it's not happening? This is the reasons, the perceived barriers that the respondents gave us. The one on top, lack of maturity, technology, and not proven interoperability. That was probably a lot more true a year ago than it is now. Things are improving very quickly. You'll see when we zoom in into the standards. Lack of demonstrable use cases, business cases. That's surprising in a way. We just saw a whole list of use cases that should have a business case attached. Maybe that's due to not fully understanding the technology and what it implies and what it enables quite yet. Hence, education sessions like this. We will now zoom in into the other ones, so standardization, equipment, and expertise. Also a bit of a look at the overhead potential challenge. So standardization, this is just a short list of some of the most important standards in segment routing. I had a slide exactly similar to this one about a year ago, and there was a lot more of drafts in progress and earlier drafts on the SRv6 column than it is today. So it really has been happening in the last 12 or 18 months. Standardization has converged, consensus is there, standards are being published. So where you see submitted for publication, that's as good as an RFC, just waiting for a number. Couple of highlights. Header compression, we'll talk about that in a second. That's something that is specific to SRv6. There used to be several competing solutions, but in the last year or so, it has really converged to two solutions that both been defined into a single draft, which will become RFC. So now that's really consolidated. It's no longer up in the air. Performance measurement. So this is random probe packets across the segment routing path, measuring things like delay and loss. Again, there were several competing incompatible proposals and drafts, which would have been different between MPLS and SRv6. It has now converged into a single draft that merges everything together. So it's going to be exactly the same solution for SR-MPLS and SRv6, which is absolutely great. And as soon as these drafts start to consolidate and get consensus, that's when vendors can start implementing with confidence. So summary, standardization, in my opinion, is no longer a concern. It may have been about a year ago, but now it's really in a very good shape. Finally, some bits and bytes. So this is how an SRv6 header, if you want, the concept looks like. It's composed of two parts. One is the one on the top, the normal IPv6 header with a source and a destination. And if you know IPv6 headers, you know there is a next header field that typically will say, well, the next header is UDP or TCP or whatever else is contained. In this case, the next header is an extension header, type 43. It's a routing extension header, so that's the part at the bottom. There are different types of extension headers, but the one we are interested in is the SRh, segment routing header. So this is really, as you can see, it's a list of segment identifiers. Each of them is a whole IPv6 address. And that's how segment routing works, but provided lists of segments for source routing. Now, obviously, this is very flexible, massive address space and so on. It also takes quite a bit of space. If you compare in your mind to the MPLS-based solution, you have each segment, it takes 4 bytes, 32 bits. And let's say you have 3, 4, 5 segments, you go from 20 bytes to a lot of bytes in this SRv6 scenario. Now, that's well understood by the engineering community. That's where header compression techniques will come in. We will zoom into those a lot in the following more in-depth webinars. For now, let's just say, yes, this is understood as a potential problem. This might, having so much overhead may be a concern, and therefore a solution is coming under the form of header compression. And finally, the other challenges raised are about the readiness of platforms. Is your router capable of running SRv6? And readiness of people. Are your managers and engineers, do they have the understanding and expertise to operate it? If we look at SR-MPLS, it's relatively easy. We have a lot of expertise there in MPLS as such. And in terms of hardware, if a machine can run the traditional MPLS, then it can run SR-MPLS because it's the same data plane. And there is one gotcha there. Quite often, older platforms have a limit on how many labels they can process in one go. With traditional MPLS, you rarely ever need more than 3. Segment routing SR-MPLS may need quite a few more, and that in some cases may be an obstacle. So you may want to be aware of that. But moving on to SRv6. So as we said, as we just saw, we have IPv6 and SRh. Now the IPv6 portion is very well supported on the routers, on the platform, and also on the hosts, looking into the data center. So that part is not a problem at all on technology point of view. However, IPv6 is not as widely deployed, not nearly as widely deployed and understood as IPv4, and especially IPv6 as an underlay is not that common. So that's where the expertise gap may come from. There are notable exceptions, well-known exceptions to this, where IPv6 has been very common for several years. For example, Japan, South Korea, and so on. But looking on the global scale in most geographies, that is an obstacle. Looking at the hardware, appropriately efficient processing of SRv6, including SRh, requires the latest hardware. It's just not possible to do it in a meaningful way on, for example, first generation Broadcom chipsets. So that's where, what you already have deployed might not be ready, and in some cases also what you may be able to purchase, the smaller routers in particular from some vendors may also not be capable at all. So not a problem you will have with Sienna, but keep that in mind. And finally, the software. So of course, the vendors need to also implement the software for enabling SRv6. Now, why it's not quite there from all vendors? Well, as we saw, standardization is quite recent, but also this is a huge investment from the vendor's point of view. It's a big paradigm shift compared to MPLS. So that's a big investment compared to what recently maybe some uncertainty in the standards. So not all the vendors went all in. Some might be more cautious than others. Again, Sienna is fully invested, but check with your vendor. And maybe another angle is that in the data center space, there's probably a bit of a lag into really developing the solution for data center endpoints. Very powerful promise, but not quite there yet in the technology. So now to conclude, let's see, hopefully we have answered the questions from the beginning. So what is SRv6? I guess I would say a new, powerful, elegant underlay transport technology. What does it look like? We had a look at that, a lot more on what does it look like and how it operates next time. Why should I care? A lot of reasons, as we saw. You probably have your own, but to really condense simplification and empower and applications. How urgent is it? Probably there is no need to go and replace your network right now, but at any opportunity you have for a new deployment or a refresh, you should really consider to go with the new technology. Adoption, especially of SRv6, are mainly limited to what we call the IPv6 native, so the ones where the expertise was already there, a better understanding of the technology was already there, so they could better make sense of it. And finally, we looked at the barriers. So again, expertise and platform readiness, probably the main remaining ones, but when we say platform readiness, probably it's more a choice of platforms. You need to be careful which platforms and operating systems you choose. So that was all the content for this morning. In the next installment, we will do a bit more of a deeper dive, looking a lot more into how does a SRv6 segment ID look like, what are its components, what are the operations that can be done on segments, a bit of how does traffic engineering works in SRv6, and if time allows, the beginning of the concept of header compression. And then will be further installments with further deep dives. If we have time, we may be able to address one or two questions.
There's a few questions that have come through, William. Obviously, in the interest of time, I don't think we get to all of them, but I'm sure that we will answer, follow up with all the questions that have been asked. Probably two if we've got time, William. If you can keep answers relatively brief, that'd be good. Can we interwork SRv6 and SR-MPLS?
Yes, there are specifications, there are ways to interwork. There's probably two conceptual ways at the high level. One is interwork at the underlay level, so you really interwork the transport with a common overlay end-to-end, and interwork at the overlay level, so you basically a service level gateway. So both approaches are possible.
Excellent. And final one, this is probably a good segue. This was asked kind of halfway through the session. Can you cover details on USID/microSID?
Well, not today, but definitely, yes, we will cover that in the upcoming sessions. Excellent.
As I said, there's a few more questions. He will follow up with the individuals in question here. So thank you, everyone, for joining. We're kind of at the 30 minutes already. If you've got any more questions, please do send them through. I invite you to connect with William and myself on LinkedIn, and we'll be happy to answer questions. Please do join us for the next technical breakfast briefing session in approximately a month's time. And we are, of course, welcome for feedback on this session, as well as where your interest lies, so that we can tailor these sessions to meet your needs. Thank you, everyone, and have a great day.